Electronic autocollimators of the Elcomat Direct N product line are the most versatile devices in the high-precision Elcomat series from MÖLLER-WEDEL Optical. They are used, among others, in the optical industry, in machine and device construction, and in the semiconductor industry. The Elcomat Direct N is suitable for the measurement of single angles as well as for the simultaneous determination of the angle difference of up to 10 surfaces. It can therefore also be used for aligning several optical surfaces to each other or for direct wedge angle measurement. In the Elcomat Direct N, the reticle image is projected through the objective lens to infinity. The collimated light beam then runs parallel to the optical axis of the instrument. When the light beam is reflected by a flat mirror, the objective lens images the reticle image onto the CCD sensor. The angle deviation of the mirror can be determined from the position of the reflected reticle image on the sensor. Operation is done by using the supplied ElcoDirect software on any standard PC. Angle measurement of two surfaces relative to each other. To illustrate the measurement of the angle between two surfaces, this example uses two mirror surfaces onto which a light beam is directed via a beam splitter cube. In order to be close to the center of the measuring range during this measurement, one light beam is first blocked and the autocollimator is aligned with a reference surface. The pre-alignment does not affect the accuracy of the measurement. Then the aperture is removed and the double cross measurement method is activated in the software. The angle difference between the two surfaces to be measured is now displayed. Wedge angle measurement. Wedge angles of transparent optical wedges can be measured directly or indirectly. Direct measurement evaluates the reflections from the front and back surfaces of the wedge, while indirect measurement measures the deflection of a light beam by the wedge. To measure the wedge angle using the direct method, the measurement method is first set to wedge angle in the software menu. It is important to specify the exact refractive index of the substrate to be measured. The wedge to be measured is placed in front of the Elcomat Direct N, and the software determines the X and Y angle offset of the front and back surfaces. The system can output the wedge angle either in polar coordinates, i.e. as the total wedge angle with the associated rotation angle phi, or in Cartesian coordinates, i.e. as the wedge angle in the X and Y directions. For indirect measurement, the deflection angle of the wedge is determined with the aid of a mirror. First, the mirror and autocollimator are aligned, and the measured angle is set as the zero reference in the software. In the second step, the optical wedge is placed between Elcomat Direct N and the mirror. The display screen now also shows the calculated wedge angle. The direct wedge angle measurement method is more accurate. However, if the wedge angle is too small, it cannot be measured because the two measurement signals cannot be separated below a certain angle difference. The size of this minimum measurable angle difference depends directly on the focal length of the autocollimator. The indirect method, on the other hand, can measure very small angular differences but is not quite as accurate. Measurement of 90-degree prisms. If a 90-degree prism is placed in front of the autocollimator to measure the deflection angle, a retroreflection occurs in the prism that is independent of its angular position. This retroreflection leads to the fact that only the amount of the angular deviation of 90 degrees can be measured, but not the sign. To determine the deflection angle of the prism with magnitude and sign, one aperture half of the prism is covered with a diaphragm to prevent retroreflection. The ElcoDirect software now determines the deflection angle of the prism, calculated from the direct reflection of the front side of the prism and the reflection of the rear side. Centration measurement of spherical surfaces. The ElcoDirect software is switched to its centration mode. The program window closes once and then opens again. For the centration measurement of spherical surfaces, an attachment acromat is screwed in front of the Elcomat Direct N in order to focus the collimated light beam. The lens is mounted so that it can rotate. The autocollimator is moved until the center of the radius of the surface to be measured is in the focal plane of the autocollimator. Exactly at this position, the corresponding autocollimation image is clearly visible in the live image of the Elcomat Direct-N. If the lens is now rotated, the autocollimation image describes a circle which is evaluated by the Elco Direct software. Depending on the software settings, the centering distance or the centering angle of the measured surface in relation to the mechanical axis of rotation is displayed. Wobbling mirror. In centration mode, the wobble of a reflective surface is shown in this example. To do this, the mirror is rotated in front of the autocollimator. The Elcomat Direct-N continuously measures the angle of the rotating surface. After a complete rotation, the Elco Direct software displays the exact amount of surface wobble and its orientation as the angle phi. Further options of Elco Direct software. In addition to the configuration of the camera and the autocollimator, various measurement scenarios can be selected. The display can be switched between polar coordinates and Cartesian coordinates, both when measuring individual angles and, for example, when measuring wedge angles. The display can also be limited to individual axes. Degrees, angular minutes, angular seconds, myrad, or lines can be selected as the angle unit. Not only the automatic cross detection or the 0 point including the measuring scale of the autocollimator can be displayed, but also indicators for the measuring accuracy of the optical signal. The so-called line section provides information about the quality of the measuring beam as well as valuable additional information for aligning two measuring surfaces with each other when the measuring signals are superimposed. Tolerance ranges can also be defined to quickly determine whether a measurement is within or outside a required tolerance range. All configuration options can be restricted to specific user groups with the user control in order to ensure process-reliable measurement with the Elcomat Direct-N. Depending on the requirements of the measuring task in terms of measuring range and measuring uncertainty, the appropriate Elcomat Direct-N can be selected from our product line.